Hello everybody. In this video we're going to talk a little bit about assumption questions on the logical reasoning portion of the LSAT exam. And a subset of those are the flaw questions. But what I feel like we need to do before we handle flaw questions, and I've got a bunch of them over here to kind of practice to go over. We'll split this up to several videos. But we need to be very clear about what constitutes an argument on the LSAT, and then from there we can talk about what would be assumptions needed to make the argument work, and then finally within that we can talk about what would be perhaps the flaw or the error in the assumption we'd have to make in order for that argument to connect. So let's just do a quick review first over what makes something a valid or an argument on the LSAT in particular, and just logical reasoning in general, and then we can go from there. I would strongly encourage you, let me know if you do a more detailed approach to this portion here. I'm going to kind of do a very quick review, but if you'd like some more on that, you can of course always Google something, but also let me know, and I'm more than happy to make another video or a series of videos. But let's just jump into this real quickly. Okay, so on the LSAT, the basic structure of an argument follows an if-then format, right? That's just the general if something, then something else follows, right? If this situation occurs, then we know that B, whatever this situation or characteristic, would have to follow. This is more formally written, and I would encourage you to get into the habit of this, of A, arrow, B. All that this is stating is that if we have this characteristic here, we know that B has to follow, whatever the characteristics are, right? If you know, I don't know, now, you know what, I'm not even going to make something up right now. Let's keep this super abstract just for a little bit. Okay, and then in the video, or in a previous video, I did mention something called the contrapositive. This is really the only thing that you need to, other than this structure here, if A, therefore B, you really want to have what's called the contrapositive down. And that is just essentially that we can, in a sense, restate this, this claim here, A, therefore B, in another way, but they're logically equivalent. I am not going to get into great detail on why the contrapositive is equivalent to this structure here, but it is important, just at the very least, to have sort of memorized, and that is, here's how you find the only other logical equivalent to this statement is what you do. We have the arrow, so I'll just write statement number 2. So this is, our initial statement, and here's the contrapositive. You first, step 1, is you flip whatever terms you have. So in this case, I had B to the right of the arrow, so now let's put B to the left of the arrow and put A in the other spot. Okay, so that's step number 1. Step number 2 is reverse, put the opposite sign on each of these terms compared to what you had here. So in this case it was, positive A, right? If I do have A, then I will have B. So what we do here is now we'd say, well, if I don't have B, then that means I do not have A. That's it. That's all you got to do with the contrapositive. Switch the terms, switch the signs. 2 steps. And this also applies if I had started with, say my logical deduction was, if I don't have A, so not A means I do have B, well, the contrapositive of that would be switch sides, and then switch terms, and then switch signs, right? So this one had negative A, so I want to leave that positive. This one had positive B. The switching the sign of that would make this negative. These are equivalent. I know I kind of went through that a little bit fast, but that's really all you have to have down, is that if you're comfortable with this idea here, if I have some sort of situation A, that leads me to B, and then the contrapositive of that would just be if I don't have B, then that means I don't have A, you're golden. Okay, now, again, I'm kind of moving fast, but let's keep soldiering on. So the way that arguments are structured on the LSAT is that you got a chain of reasoning, because we want to be able to draw a conclusion, some sort of takeaway from a couple of pieces of evidence, and conclusions are usually sort of, if you want to be geeky about it, written with a little three dots here. So let's keep it real simple just for a moment. So I would have, supposing I had an argument like this. First thing I said was, if I have A, that means I have to have B. And then I said, well, also, if I have B, that means I have to have C. My conclusion would be, is there some way I can put these two things together and derive a sort of a shorter, more concise chain of reasoning? And yes, we could. We could say, if I start with A, well, that means I lead to B, but if I know if I have B, that means I lead to C, so I could say A is going to get me to C. All right? That's really it. This, in a nutshell, is your idea of logical reasoning on the LSAT. The key, though, in order to make this conclusion, is we have to have some linking idea, some linking term between these two different statements. So here's my first statement here. Here's my second statement. They have to have something in common in order for me to kind of make the leap from statement 1 to statement 2. And in this case, the bridge or the link is they both have this idea B, right? If A, therefore B, B, therefore C, so I can plug those things together. Now, this is very critical. This is where assumption questions come in on the LSAT. So I'm going to clear up a little space. I'm going to show you what I mean by this. Supposing, actually, let me just do this for a second. Let me select a little bit here. Let's get rid of that. Let's cut that. Sorry, but I probably should have just paused the video and cleaned it up and then resumed. I'll do that next time. But here, let's suppose this. Supposing I did the same sort of three-part structure. I've got one claim here, and then a second claim here, and then my conclusion. Generally speaking, that's how most arguments on the LSAT are formed, right? We have two pieces of evidence that then lead us to some kind of conclusion, two statements. So supposing I gave you this. Let's make it somewhat easy. Supposing I said, all right, well, I've got A, that leads me to B. Okay? And then I say, well, okay, therefore, my conclusions, I just gave one statement. Therefore, if I have A, I must have ended up with C. Well, something's missing right now, just from this statement, right? If I said A, therefore B, if I have this situation, I end up with B, and so I said, okay, well, therefore it must mean that if I have A, I end up with C. Well, there's no connection here. There's no link, right? In this scenario here, we had a link between, B gets us, B is the link that goes from A to B, then B to C, but I don't have that. There are only two. I should be careful about saying only. Let me just say the primary, the ways that we can have this, to rectify this situation is figure out what is our missing piece. What do I have to put right here, sort of in the middle, to get me from A to C? This is what we mean by an assumption. What is missing? And there are really just two basic types. If this is my format here, I can do one of two things. I can say, oh, okay, I can say A goes to B, and if my conclusion is correct, A goes to C, B and C must be the same thing, must be equivalent in some way. Think about that for a minute. That's one way to fix the problem, right? B equals C. So, for example, let's make this stupid, but if I said, person A, if you enjoy hamburgers, then you must love hot dogs. Let's just say. Obviously, it's not necessarily true, but, bear with me for a moment. If I love hamburgers, then I must love hot dogs. So we could say, if hamburger, then you must love hot dogs. HD, hot dogs. Okay, and then I said, oh, my conclusion is, oh, he loves hamburgers, therefore, he must love, bratwurst. Okay, well, these things do not connect. This is not a logical conclusion. Something's missing, right? All I said was hamburgers leads us to hot dogs, but then how do I get from hamburgers then to bratwurst? Well, one way that we can connect this is say, well, maybe I can make another, I can insert another statement in the middle there. I could say, well, those two things we could say. Hot dogs are the same thing as bratwursts, which of course they're not, but just pretend for a minute here. So these things are equivalent. Or, the other option number 2, put that down. So we have option 1. If a hot dog just means the same thing as a bratwurst, then well, duh. If I like hot dogs, that must mean I like bratwurst because they're the same thing. That's option 1. Option 2 is, how do we go from this to this? I could make this the claim, well, if you like hot dogs, then you must like bratwurst. If that assumption is included in this list here, right? If we go, hamburgers means we like hot dogs, and our conclusion was, well, therefore, if you like hamburgers, you must love bratwursts. Well, if I throw that in there, if you like hot dogs, therefore you must enjoy bratwursts, the chain is complete, right? This is a valid deduction here. This would be the missing piece, the assumption I would have to be making in order for that chain to, the conclusion to be valid. Okay, this is running kind of long, but more in the next video on this. But hopefully you kind of, the takeaway here is if I'm missing a component in my argument, All right, if I went A to B, but then I said A to C, there's only two ways that we can fix this. Either, actually I should change up that hot dog versus prosper, just ignore that for a minute. Either I could say, well, B is equivalent to C, right? This term is the same as that term. Or, the other thing I could say is, if I have B, then that must mean I end up with C. One of the two. That is your key to resolving assumption questions. More on this in the next video.